Welcome, this is Math 111, and this is section 1.7 in your textbook, which covers absolute value equations and inequalities. So first, let's just take and talk about what the absolute value is. It's a metric. And it really tells us how far away the magnitude something is away from zero. So 3 is 3 away from 0, but so is negative 3. So if I have the equation, absolute value of x, we represent the absolute value with these two straight bars, equals 3, there are two places that is true. One's for 3 and also negative 3. Let's do some simple. This, how far away is negative 7.2 from 0? It is 7.2 steps. How far away is negative pi from 0? It is pi away. How far away is negative root 2? It is root 2 away. How far away is 0? 0. So how far away is 17? 17. How far away is 23? 23. How far away is negative 23? 23. So if I was to write this as a piecewise function, here's my function notation, I would say wherever x is greater than or equal to 0, you just get x out. But wherever x is negative, you would get the opposite of x out. Okay. So what this looks like on a graph, 0 gives me 0, 1 gives me 1, 2 gives me 2, 3 gives me 3, and so on. It goes up that way. And 0 gives me 0, 1, negative 1 gives me 1, negative 2 gives me 2, 3 gives me 3, this way. Right? Sorry, that one's a little offline there. All right, so it looks like a V-shaped thing. Comes down to a V. Now, let's talk about how we solve equations that involve absolute values. Let's just take a look at a few of them. Now, this means that everything inside here could be equal to 8, or the opposite of everything inside here could be equal to 8. So this would be, so when I'm solving these, I tell students this, I find this to be the most successful way to do it. There's lots of different methods that you hear. I find this way has the least ways to mess up. So to solve for your first equation, just ignore the absolute values and solve it like normal. The second equation, bend the absolute values and put a negative in front. You won't go wrong if you do that. Bend the absolute values and put a negative in front. So add 4 to both sides. X equals 6. 12 minus 4 is 8. The absolute value of 8 is 8. All right, distribute. Subtract 4 from both sides. Divide by negative 2. X equals negative 2. Negative 4 minus 4 is negative 8. Absolute value of negative 8 is 8. So I would go ahead and divide the 4 out first before I This is equivalent to t plus 5 is equal to 4. So t plus 5 equals 4, or the opposite of t plus 5 equals 4. T equals -1, or t plus 5 equals -4, dividing both sides by a -1, t equals -9. Right? Put this back into the original equation. 4 times -1 plus 5. Does that equal 16? 4 times the absolute value of 4. Does that equal 16? 4 times 4 does indeed equal 16. Times -4. This absolute value is 4, which indeed equals 16, right? So, all right, now where we really get to have some fun is when we're talking about inequalities. Let's take a look at what's just graphically what this looks like. This is basically a line that goes up 3, over 1 up 3, over 1 up 3, through the origin, on both sides. That's what that looks like. 9, if I count up to 9, so here's 3, 6, 9. You can see it is saying anything greater than this, anything above this line, which would be these numbers and these numbers. It's an or statement. When you have a greater than sign, then it's going to end up being an or statement, because what you're doing is you're taking that graph and you're cutting it, and the things that are above end up being your range. So if I were to do this absolute value, I would do this twice and say 3x is greater than 9, or the opposite of 3x is greater than 9, which would tell me that x is divided by 3, x is greater than 3, or -3x is greater than 9, divide by -3, divide by -3, flip the sign because I'm dividing by a negative. So I would have these two ranges. Look at how that matches here. This is -3, this is 3. I have all these points going this way and all those points going that way. So this would be how I'd write it in inequality using bracket notations. I'd say everything from -infinity up to -3, not including 3, or use the union sign, everything from 3 up to infinity. Now you'll notice, if this was a less than sign, it would be a continuous little thing, an and. It would be all of these from here, this to this, and. So let's do one like that. Suppose I'm having 2x. Let's do it on a new page. 2x plus 4 less than 10. All right. Now let's think about what this looks like. Just a note. On this side, I have, that makes that go up 4. Excuse me. Then I'd have kind of a slope of over 1 up 2, over 1 up 2, So it would look like this. It would be straight. And if I go up 6 more, here's 10, and I'd be looking at this range from here to here. Let's solve it algebraically. It would be this, less than, and the opposite, bend those, change the sign, right? And then got 2x minus 4 from both sides. X is less than 6, so that's our point over here. Distribute this, add that, divided by -2, divided by a negative, switch the sign, x is greater than -7. That's our point over here. So we would have, I was just thinking to myself, that doesn't really make sense. Why is it 6 this way and 7 the other way? It seems like it should be more symmetric than that. And then I looked at my math. I realized I divided by 2. I forgot to divide by 2. There we go. All right. So it should look something more like that. This is going to end up coming like, I get it more like this. There we go. Okay, so we have all the numbers. X is less than 3, is greater than -7. We'd write that like that. And then for our interval notation, we go from -7 to 3. Now this is an and statement, so we're including that. Okay, so I think what we'll find is tricky is when you have something like this. Let's just try this one. Okay. We have x is minus 4, the absolute value of x minus 4 is greater than -10. Right. So let's say I just solve that. Like I hop in and say, okay, she said that we do it this way. It's an or statement. And then we do it, bend the brackets. Okay. So if I add the 4 to both sides here, I get x is greater than -6, or I'm going to have x minus 4. I'm going to flip the sign, change that to a positive 10, or x is less than 14. So what a lot of people will do then is they'll forget that this is an or 6, and they'll say, oh, it's between -6 and 14. But that's not true. It is saying all the things bigger than -6, or all the things less than 14. You'll notice that that is all real numbers. That covers every number on the line. You have to be, there's no real number that you can think of that is not either greater than -6 or less than 14. So my answer would actually be this. Now, I could have noticed this right here, the very beginning. Any absolute value has to be greater than a negative number. So just looking at this right here, I could have deduced from the very start, without doing any of the other math, that this was always going to be the case. It will also be the case that sometimes you'll get something that has no solution. Something like the absolute value of x plus 3 is less than -2, right? An absolute value is always positive, so it can never be less than -2. So in this case, the answer does not exist. So this would be the empty set, but usually on the computer system, you would write DNE there. All right. Just do one more for fun, and then right, so this is a greater sign, so I do it, drop them, do it like normal. Or greater, and then bend the brackets, make it negative. This is x plus 5 is greater than 24, so x is greater than 19. Or I can get rid of that negative right away. X plus 5 over 8 is less than or equal to less than negative 3. X plus 5 is less than negative 24. X is less than negative 29. So on my open math, I would write from negative infinity up to negative 29, not including, union, 19 to infinity. All right, so this is section 1.7. Hope you guys all have a great week.